Facts Only Test Prep.
Welcome to Facts Only Test Prep. We're called Facts Only because we give you everything you need and nothing you don't when it comes to the SAT. So please enjoy the next video.
Term placement.
There is a family of questions that looks very, very intimidating for two reasons. Number one, it deals with polynomials, and those always make us think of higher order calculations. Number two, there are usually more letters than numbers. I know that's kind of a rudimentary way to address constants and variables, but when I look at a question like this, I tell myself, boy, there's too many letters and not enough numbers. And when you have that impulse, you should be thinking about using term placement to solve for some of those values. I'm going to show you how to do that today. You're going to need Test 2, Section 3, number 17, Test 1, Section 3, number 15, and Test 3, Section 3, number 17. Pause the video and go to factsonlytestprep.com right now. You can click on the links to those tests if you need to. Let me show you what I'm talking about. This is Test 2, Section 3, number 17. We're given a polynomial on the right here with no numbers except for the exponent 2. And then we're given a lot of mess over here on the left. And we're asked for the value of b. And that's our b right there. They want to know the value of the b constant. The trick to using term placement with polynomials is to make one side look as much like the other side as possible. In this case, we're just going to distribute all of the information and then combine like terms. And I'm going to distribute as if you know how to distribute. So I'm going to go kind of fast with this. 2x times 3x is 6x squared. 2x times 5 is 10x. 3 times 3x is 9x. And 3 times 5 is 15. Okay, now we're going to combine like terms. There's an x squared term, but no other x squared term. So our first term will be 6x squared. I've got 10x and 9x. Those add up to 19x. And then I've got 15 all by itself. That's my constant. And so my b term is the coefficient of the first degree x value. b equals 19. And this is a bubble in question, so you would actually bubble in the numbers 1 and 9. Notice that once I get 6x squared plus 19x plus 15 to look like ax squared plus bx plus c, it's just a matter of what term occupies what position. If they asked for my a term, I would have told them 6. If they asked for my c term, I would have told them 15. But the point was that b is 19, so don't sweat that c term. I'm going to show you a more complex version of a question like this right now. This is Test 1, Section 3, number 15. And look, here we have it again. We've got a x and a bx and a cx. We've got a lot of letters. Too many letters, not enough numbers. Now, the question does give us a couple of hints. They're telling us that a plus b equals 8. That is going to come in handy in a moment. But for now, remember what I said, we just want to make this side look like this side, and we're going to do that by distributing ax plus 2 into bx plus 7. I'm going to FOIL it all in. So ax squared times bx is a bx squared. Ax squared times 7 is 7ax. 2 times bx is 2bx. And lastly, 2 times 7 is 14. It's a nice little heads up that you're doing things correctly when your constants are the same. So our C terms are already correct. We know that 14 equals 14. That's nice. 15x squared should be equal to whatever the x squared coefficient is down here. So if 15x squared equals abx squared, we can say that 15 equals AB. Look at our answer choices. We're dealing with all whole numbers, so we're probably not going to have any decimals or fractions. Let's think about two numbers that have a product of 15. The first two numbers that come to mind for me are 3 and 5. We could also say 1 and 15. We've also been told that a plus b equals 8. So what are two numbers that add up to 8 and have a product of 15? Those are 3 and 5. Here's the catch. We don't know if A is 3 and B is 5, or if B is 3 and A is 5. That's why all of the answer choices have two possible answers. That's fine. Let's start plugging these values in for A and B. And I'm going to write that A can be 3 and 5, and B could be 5 and 3. Either way, we're pairing 3 and 5 in different combinations. So if we let's start with putting 3 in for A and 5 in for B. If we start off with 3 times 5x squared plus 7 times 3, again, A is going to be equal to 3, 7 times 3x plus 2 times 5x plus 14. This will simplify quickly to 15x squared plus 21x plus 10x plus 14, or 15x squared plus 31x plus 14. Our term is 31. Only one of our answer choices has 31. That tells us that D is the answer. I want to get to another example, so I'm going to explain quickly, but without doing the calculations, that by putting 5 in for A and 3 in for B, we would have arrived at 41, the other answer in answer choice D. All we had to do was make the left-hand side look like the right-hand side, and then look at term placement to determine the values of the first, second, and third coefficients. This is test 3, section 3, number 17. This looks awful. And if you go into this without a plan, you'd better really know your polynomial rules. If you've gotten used to this idea of using term placement, you should be able to make the left-hand side look like the right-hand side and then match terms. This information right here, that x cannot equal 2 over a, is irrelevant. Most of the time, when you're told that a variable can't equal some value, it's just to avoid having a 0 in the denominator. I've probably already said too much. Don't worry about it. Let's get right on to solving this. I've got a nice looking polynomial here on the left-hand side, so I'm going to do whatever I need to make the right-hand side look more like that. Another clue is that the entire left-hand side has a denominator of ax minus 2. If I multiply the right-hand side by ax minus 2, over ax minus 2, I'll have a right-hand side in which every term has a denominator of ax minus 2, just as the left-hand side does. So quickly we will say that negative 8x minus 3 minus 53 over ax minus 2 is multiplied by ax minus 2 over x minus 2. You know, you could actually multiply both sides by ax minus 2 and get to the same result. But we're not going to lose any time doing it this way. All right, so the first thing that happens is ax minus 2 is canceled in the negative 53, and now we're just multiplying negative 8x minus 3 by ax minus 2. We have to FOIL. We get negative 8ax squared. If you've been paying attention in term placement, you might realize that that's all that you need, but we're going to follow this all the way to the end. Negative 8x times negative 2 is 16x. Negative 3 times ax is negative 3ax. And lastly, negative 3 times negative 2 is positive 6. And let's not forget that we had our negative 53 from up top. We'll put that in. And again, not a coincidence that positive 6 and negative 53 give us negative 47, which is also the constant of our left-hand expression, which is, again, always a good sign. What are they asking us for? The value of a. Remember, term placement. My x squared term, in this case, negative 8x squared, should be equal to my x squared term on this side, 24x squared. So I can say that negative 8ax squared equals 24x squared. And I'm going to divide both sides by negative 8x squared. And I'm going to get that a equals negative 3. Again, I know that's a lot of writing on the page. I know that's not easy. All of these questions are higher level questions. These are where you really steal some points. So hopefully watching this video once helps you understand the concept. Go back, watch it a few times, copy my steps, build some muscle memory with this. That's the way to master this content, and when you see it on the real test, it won't seem so scary at all. Good luck, everybody. Hey, thanks for watching, everybody. Make sure that you like us and subscribe and hit the notification bell. That way you'll get information on the new videos as soon as they're available. It helps us a lot. Also, visit us at factsonlytestprep.com. That's where you'll find links to the tests that I use in my lessons, along with some other resources that we prepared for you. Thanks and good luck.